Hi there, welcome back to Think Tank Online Learning. So in this video, we're going to look on Fourier Series. So if you're looking for other videos like this one, just go to the description. And I'm going to see a playlist named Fourier Series and Laplace Transforms. You click on that, you're going to get various videos of Fourier Series. Okay, so I've made another video on how to calculate the Fourier Series of f of x equals to mod of x. If you just like it, you go there and see it. And I also made other videos on Fourier transforms. Okay, so without wasting your time, let's look at this function. Okay, so we have f of x, let f of x be a function of period 2 pi. Okay, so it's a periodic function of 2 pi. Okay, now f of x is a piecewise 1 from negative pi to 0 and 0 from 0 to pi. Okay, so the first equation is to sketch f of x in the interval from negative 2 pi to 2 pi. Okay, so for this one, I'm going to take our ruler and I'm going to sketch my xy plane. But in this case, it's not going to be the xy plane because we're not given the y, but just know here we're going to have f of x and you're going to get the x. So it's going to be x f of x plane. And we're going to use what we know. So we know that from negative pi to positive pi, so we're going to have 2 pi here, we're going to have negative 2 pi here. Okay, so from these inequalities, you know that negative 2 pi is not included and positive 2 pi is not included. But you know that from negative pi to 0, we have 1. Okay, so I'm going to say my 1 is right here. So I know from negative pi to 0, it's 1. Then from negative pi, from 0 to positive pi, it's going to be 1. Since it's a periodic, it's going to repeat itself. So I'm going to write it here and sketch it up to here. And I'm going to write a small circle right here, and I'm not going to shade it to show that 2 pi is not included. And right here it's going to come down, so that means from here it's going to go up to 2 pi. Okay, so to show that 2 pi is not included, I'm going to write a circle and I'm going to shade it. Okay, and what is going to be our next question? For part A, it's done just like that. For part B, we want to find the Fourier series of f of x in the interval negative pi to pi. Okay, and you know that the Fourier series of a function, let me just write f of x is given by a naught over 2 plus the summation from n equals to 1 up to infinity of a n is a Fourier coefficient cos going to be n x pi over L plus bn, another Fourier coefficient sine nx pi over L. Okay, and if you don't know how to calculate a naught, so in a naught is going to be 1 over L from negative L to L of f of x dx. Okay, many people have a problem here, or they don't understand it. They say it's 1 over 2L. Okay, if you just say 1 over 2L, it's fine. But make sure you're not going to put a naught over 2 here. You're going to put a naught only. And we're going to write for an, it's going to be 1 over L, negative L to L. You're going to have f of x times cos nx pi over L. And we're going to write dx. If your function is form of t, write it as dt. Let's go to bn, 1 over L, negative L, and we're going to have f of x, and we're going to have sine terms here. It's going to be sine nx pi over L dx. Okay? Okay, so this one is for sine, if you haven't seen it. Okay. And now, you have to be careful, especially when you're given piecewise functions. Okay, so you have to treat them separately. To just rewrite the equation here, f of x is going to be 1, 0, negative pi x to 0, and 0 x to pi. Okay, and let's start by calculating a naught. Okay, so for a naught we're going to have 1 over pi, since it ranges from negative pi to positive pi, so it's going to be 1 over L. And we're going to have, since it's a piecewise function, first we're going to start with this one, from negative pi to 0 of 1, and we're going to have dx plus 1 over pi from 0 to pi of 0 dx. Okay, and we're going to have 1 over pi, and this one's going to become 0 because you have whatever you're going to get, you're going to multiply it by 0. Let's integrate 1 with respect to x. We're going to get x from negative pi to 0, and we're going to say upper bound minus lower bound. We're going to have 1 over pi If we say 0, I'm going to say 0 minus pi. Okay, I have to take note of the sign. And we're going to have pi over pi, and that is going to give us 1. So our a0 is 1. Now let's move on to an. So I said an is 1 over pi, okay, from negative pi to 0 of 1 times cos nx pi over L, which is pi, and it's going to be dx. And for this one, I can't just write it because I know it's going to be 0. So again, you can write plus 0. You can just leave it, okay, and we can see that pi over pi is going to be 0 here. So I'm going to have 1 over pi, and the integral, of course, it's sine. So I'm going to have sine nx, but don't forget to divide by the derivative of the angle. So we're going to have n here from negative pi to 0, okay. And there's something that you need to know. You have to know that sine 0 is equals to 0, sine pi is equals to 0, sine n pi is equals to 0. You can just punch it on a calculator. Let's say for forgotten examination, sine 300 pi, sine 20 pi, sine 2 pi, you're going to see that it's going to become 0. So if I say plug in sine 0 here, I'm going to have 0. Plug in sine negative pi, I'm also going to get 0. So we can just say an is equals to 0 right here. Okay, so now let's move on to bn. Bn, I'm going to write it here. It's going to be 1 over pi, negative pi to 0 of 1. Now it's now sine n pi x over L, which is pi. I'm going to write dx plus, this one's going to become 0 again. So I'm going to have 1 over pi. Okay, so for this one, it's going to, which is becoming 0, there's some lecturers who just want to make things hard for people. Okay, so they may just deduct the marks. So it's better to write 0 and show they might get 0. Okay, it happens. You know, some people may want to see everything, even if that thing doesn't change anything, but they just want it. So if we integrate sine, you have to know that we're going to get negative cos, and you can just cancel pi here, and we're going to have nx divided by the derivative of the angle, which is equal to n from negative pi to 0. Okay, and there's something that you have to know. Cos 0, that's going to give us 1. Cos pi, that is going to give us negative 1. Cos 2 pi, that's going to give us positive 1. Cos 3 pi, that is going to give us negative 1. So I'm going to say that this value changes from negative 1 to 1. That's why it oscillates. It depends on the value of n. If it's even, you can say it's positive. If it's odd, it's negative. So you can just say cos n pi is equal to negative 1 over to the power n. So if n is even, you can see we have a positive number right here. Okay, so now what we're going to do, we can now write this one. Okay, for this one, I'm not going to do some shortcuts. I'm going to write it as it is. So I'm going to say dn is going to be 1 over pi. Okay, upper bound, we have negative cos 0 over n, right? Minus the lower bound, I'm going to say minus for this one. Now, I'm going to write minus for the subtracting the lower bound. I'm going to have cos negative n pi, right, over n. And what's going to be the answer? Going to be 1 over pi. And here we're going to have negative 1 plus cos negative n pi. Okay, so cos negative n pi. Let me confirm it on my calculator. Negative n pi. Okay, it's just going to repeat the same here. So I'm going to have negative 1 to the power n, right? Or divided by n, or save n and n. If we have something in the same denominator, we're going to get the same answer. Okay, so now what is going to be the answer here? Okay, so some of you, if you don't know how to deal with this negative 1, you can just leave it here. Okay, so that means let's leave it there. 1 over pi, and I'm going to have positive and positive here, and this one is going to give us 1. So I'm going to write it as cos 0, which is going to be 1. So I'm going to write it as cos negative n pi, right, minus 1 divided by n. Okay, so I'm going to write my bn as cos negative n pi minus 1 divided by n times pi. Okay, you know that cos negative n pi and saying cos n pi, just the same thing, nothing's going to change, over n pi. Okay, so now let's write our Fourier series. Okay, so we have said that f of x is equals to a naught over 2. And what is our a naught? Okay, our a naught is equal to 0. Okay, it's 1. A naught is equal to 1 going to say 1 over 2. I'm going to say plus the summation to infinity. They said our n was equal to 0, so I'm just going to have bn right here. And what is bn? Bn said it's cos n pi minus 1. Cos n pi minus 1 over, it's over pi, it's over n pi, times sine nx pi over L, which is also equal to pi. Okay, in this one, we cancel this one. Okay, so our Fourier series is going to be 1 plus the summation is n from n equals to 1 up to infinity cos n pi minus 1 divided by n pi sine nx. So on part C, we want to prove that pi upon 4 is equal to, and prove that pi upon 4 is equal to 1 minus 1/3 plus 1 over 5 minus 1 over 7, going so on. Okay, so what we're going to do here, we're going to use what we have. We say that f of x is equal to 1/2 plus the summation n from 1 up to infinity, said cos n pi minus 1 over n pi here times sine nx, right? Okay, so this is what we're going to use. Okay, so we're going to test. I'm going to start with n equals to 1. What is going to happen when n equals to 1? Okay, so when n equals to 1, I'm not going to include the half here. I'm going to test here. We're going to have cos pi, right, minus 1 over pi here times sine x. Cos pi, we know it's cos pi is negative 1, right? I'm going to have minus 1 divided by pi sine x. That's going to give us negative 2 over pi sine x. Okay, let's go when n equals to 2. What is going to happen? Going to have cos, going to have 2 pi here minus 1 over 2 pi here times sine, going to have 2x. Cos 2 pi is positive 1, so I'm going to have negative positive 1 minus 1 over 2 pi sine 2x, and that's going to give us 0. Let's try for n equals to 3. Okay, so if you're someone who understands trigonometry, there's no need for doing all this, but some lectures may want to see it. Okay, so let's just do it. Cos, we're going to have 3 pi here minus 1 divided by 3 pi sine 3x. We're going to have negative 1 over 3 pi sine 3x, and we're going to have negative 2 over 3 pi sine 3x. So now we have our pattern. When n is equals to odd, equals to even, we're going to get 0. When n equals to odd, we're going to have 1 over, right here we're going to have n, and here we're going to have negative 2. So from here, we know we need 3, we need 5, we need 7. So that means we want n equals to 1, n equals to 3, n equals to 5, and n equals to 7. Okay? So I'm going to write f of x is equal to, I'm going to write here 1/2 for this one. I'm going to write plus, we have negative 2 over pi sine x, negative for 3, negative 2 over 3 pi sine 3x, negative 2 over 5 pi sine 5x, and negative 2 over 7 pi sine 7x. Now going to estimate an angle. So the angle is going to be x equals to negative pi upon 2. And some may want to know how I calculated this angle. Okay, so it said estimate. Actually in this question it doesn't just say insert otherwise. So I estimated the angle. So I know that my fx is equal to piecewise continuous function 1 here, 0 here. Okay, so I just said let my sine x be equal to 1, and I see that x was equal to pi upon 2. Then I tried to plug in pi upon 2 and it didn't work out. Then I tried negative pi upon 2 and everything went smooth. Okay, so I'm going to write here x equals to negative pi upon 2. So on the left hand side we have 1 for this one, okay, and you're going to have 1/2 plus, okay, I think it's good if I just factor out negative here, negative 2 pi, since it's common, 2 over pi is common, as you can see. I'm going to write minus 2 over pi, and I'm going to have sine x minus sine 3x over 3 minus sine 5x over 5 minus sine 7x over 7. Okay, and let's plug in, or let's substitute. Okay, so we're going to have 1 is equal to 1/2 plus negative 2 over pi sine negative pi upon 2 right here. Okay, so if I plug in negative, you can see this one should be positive, since I have all negative terms here. And I'm going to have plus sine 3 times negative pi upon 2 over 3 plus sine 5 negative pi upon 2 over 5 plus sine 7 times negative pi upon 2 over 7. And now it's time to do your calculations. And if you do your calculations correctly, we're going to have 1 equals to 1 over 2 minus 2 over pi. And here we're going to have negative 1. And here we're going to have positive 1/3. And here we're going to have negative 1 over 5. And here we're going to have positive 1 over 7. Okay, and what is going to be, what next? We're going to move this half to this side. We're going to have 1 minus 1 over 2 is going to be equal to 2 over pi, not forgetting the negative. So let's just distribute it inside. So we're going to have positive 1 minus 1/3 plus 1 over 5 minus 1 over 7. Okay, and you're going to have 1/2 is going to be 2 over pi, 1 minus 1/3 plus 1 over 5 minus 1 over 7. Almost done, but we need pi upon 4 here. So I'm going to multiply both sides by pi and divide both sides by 2, so that we can cancel this one and this one and this one and this one. We're going to do the same here. We're going to need pi here and over 2. And if we do that, since I'm running out of space, can allow me to write here in singularity. We're going to have pi over 4 is going to be equal to 1 minus 1